Hello everyone. This is the video which is the continuation of hydrolysis of amides and as well the chemical properties, particularly reduction of amides. So let us continue further. Again I am going to talk about two things: substituted amides and the simple amine with a base or alkalis, how the hydrolysis happens, and the reduction of amides using tetrahydroaluminate, lithium tetrahydroaluminate in dry ether. Okay, let's start with first the alkali hydrolysis of amides. Okay, let me take the general formula for simple amide. Like in the previous video, I'm going to have a different color for the amino group. So I used the blue color in the previous video, so I'm using the same color code. So this is the amine group in the amide. So now what we are going to add is, we are going to add alkali, that is sodium hydroxide aqueous. Again, the hydrogen of sodium hydroxide, that is going to be in blue color because it is going to get attached to the amine group present in the amide. ONA, I am writing sodium hydroxide aqueous to just to simply understand. So now when I consider, I'll get RC double bond O, ONA. So this is sodium carboxylate. Sodium carboxylate. This is a simple amide, it's not substituted. This is the alkali. So now what else I'll get? I'm going to connect the blue ones. I am going to get ammonia, not ammonium ion, which was in the acid hydrolysis. Here it is alkali hydrolysis, so I get ammonia. So let me take a general or else a specific example. Let us say ethane amide. Ethane amide should have two carbons, so that's why I have two carbons, and it has a amide group, and it is hydrolyzed using alkali NaOH aqueous. So the products will be sodium carboxylate, here it is ethanoate, because it is the sodium salt of ethanoic acid. So sodium ethanoate, and I have taken ethanamide, which is a simple amide, and I have sodium hydroxide, which is the alkali. And along with the sodium ethanoate, we will get ammonia. Again and again I am saying it's not ammonium ion, it is ammonia. Ammonium ion will be the product when you do the hydrolysis in presence of acid, like dilute sulfuric acid, dilute hydrochloric acid. Now we are moving further with substituted amide. What I will get? When I use substituted amide, what I will get? Let me use first the general formula. This is the substituted amides general formula. You have two different alkyl groups. This is the substituted amide. And it is reacting with, again I am using the same color code, Okay, let me change this into blue so that I can show the bond cleavage properly. So N H R dash. Now again I am using a alkali, which is sodium hydroxide. Which will result in, as usual, sodium carboxylate. I am just connecting the yellow ones. This is sodium carboxylate. The other one is going to have H N H R dash. This is primary amine. This is a primary amine. So it's not ammonia, it is the primary amine we are getting. Let me take a proper example, which is CH3C double bond O NH, let's say CH3. This is N-methyl ethanamide. Again, you are using alkali, sodium hydroxide. Usually we write sodium hydroxide NaOH simply to know how the bond breaking happens. So I am writing in the different way. So I am going to connect these two to get a product, and as well I am going to connect these two portions to get a other product. So the main product is sodium carboxylate. This is sodium ethanoate. I used ethanamide, so I am getting sodium ethanoate, and I will get HNHCH3, which is methylamine, which is a primary amine. If at all I want to convert this acid salt, that is sodium carboxylate, I can use dilute acids to acidify. So this can be used with dilute NaHCl or dilute H2SO4. So it becomes carboxylic acid. The salt become carboxylic acid, and you'll get NaCl separately. So this is ethanoic acid. So in all the reactions above, you can do that just to add dilute HCl, so that you will get the ethanoic acid, okay, or the corresponding carboxylic acid. So what did I do about the hydrolysis of amides in presence of alkali? What did I say is, if it is a simple amide, I will get with alkali, I'll get sodium carboxylate and ammonia. If it is a substituted amide, with alkali, the hydrolysis, I'll get again sodium carboxylate and an amine. You'll get amine. So this is what we learnt until now. Now I am going further with the reduction of amides. So when I go for reduction of amides, this reaction we have seen already in the preparation of amines. So the reducing agent we use here is lithium tetrahydroaluminate. So lithium tetrahydroaluminate, and with this we will use dry ether. So if I take RC double bond ONH2, which is a simple amide, when I use reducing agent, I represent the reducing agent by the square bracket H. The double bonded oxygen will be replaced by 2 hydrogens, and the oxygen will be removed as water. So what we are having is, we have an amide. This is the reducing agent. I can say it is in dry ether. I get a primary amine and water. Take a specific example. I am taking ethane amide. And I am using reducing agent in dry ether. I'll get the double bonded oxygen replaced by 2 hydrogens, and the oxygen is carried out or removed as water. So this is ethylamine, which is a primary amine. And how many hydrogens? 1, 2, and here there is 2. Totally 4 hydrogens we added. So here also 4 hydrogens we added. That is supplied by the reducing agent. If I take a substituted amine, the same thing happens, but the product is going to be secondary amine. In dry ether, again I will replace the double bonded oxygen by 2 hydrogens, and you will get water. So it is a secondary amine. Let me take a specific example. The same example like the previous one, N-methyl ethane amide. Let me use 4 times the nascent hydrogen, or else the hydrogen from the reducing agent, dry ether. You will get the double bonded oxygen replaced by 2 hydrogens, and the remaining acid is plus water. So this is ethyl methyl ether. So you got a secondary amine. So to consolidate, what are the reactions we have seen for amides? So let me say, if it is a simple amide like RC double bond ONH2, you can use reducing agent in dry ether. You will get a primary amine. you can use water to hydrolyze in presence of dilute acid. You will get a carboxylic acid and ammonium ion. You can use alkali aqueous. You will get carboxylate ion, sodium carboxylate, which is a salt, then ammonia. This is about the simple amide. When I go for substituted amide, R C double bond O NH R dash. Again, when I use reducing agent like lithium, aluminum hydride and dry ether, I'll get RCH2 NH R dash, which is a secondary amide. If I use hydrolysis with acid, dilute acid, I'll get a carboxylic acid plus alkyl ammonium ion. If I use sodium hydroxide aqueous, I'll get sodium carboxylate and a primary amine. So this is what we have seen as properties of amides. Thank you for watching.